Okay, here's my second, I guess, what would you call this, sort of Khan Academy style lesson for you guys. And this time I want to focus on something that people seem to have trouble with in the review session this week, and that was predicting the products of a double replacement reaction. So first I'm going to start with writing out the reactants of a reaction. We'll start with MnCl3. And that's going to react with K3PO4. Okay, there's not going to be a lot of room here. This, by the way, is problem number 95 on page 244. Okay, so this is a double replacement reaction, which means that the cations are going to switch places, basically. You're just doing a big square dance. So manganese is going to switch places with the potassium. And you could also, or you could look at it this way, that the chloride is going to switch places with the phosphate. Now, so we've got a couple of issues here that came up in class. First of all, when you look at this, you've got to realize, what do I know the charges of, and what am I going to have to figure out the charges of? You should realize that potassium here has a +1 charge when it's a cation, and that chloride here has a -1 charge when it's an anion. So those are two charges that you can know for sure. You can use those two charges to figure out the charges of the other things. Now, the phosphate over here, you could sort of put that in parentheses. The phosphate, if you had your polyatomic ion sheet, you would know that the charge on that was -3. But even if you don't have that with you, you can sort of reason through the fact that since there's 3 potassiums there, and each one has a +1 charge, my total positive charge here is +3, which means my total negative charge has to be -3. And since the phosphate is one ion altogether, we can assign it a -3 charge. Now over here, for the manganese 3 chloride, we know that there's 3 chlorines. Each one has a -1 charge, so I have a total negative charge of -3. That tells me that this single manganese ion here is going to have a +3 charge. So in that way I can discern what all the charges are, and that's going to be important when it comes time to predict the products, because all we're doing is switching products. So now the manganese is going to match up with the phosphate, and luckily manganese has a +3, phosphate has a -3, so I can write that product as manganese phosphate. No parentheses necessary because phosphate. The other thing I have is potassium chloride. Now please resist the urge to write K3 with Cl3 for a couple of reasons. First of all, when you write an ionic compound, you want the formula to be reduced to the lowest whole number ratio, and 3 to 3 could be reduced to a 1 to 1 ratio. So let's get rid of that. And think about, what are the charges of these things? Well, potassium has a +1 charge. Chlorine has a -1 charge. That's a 1 to 1 ratio. So really all we need is KCl. That's it. So your job when you're predicting the products is just to write the correct formulas. You don't need to concern yourself with how many there are. So don't worry about those 3's up there with the potassium and with the chlorine. Your job is to write the correct formula, and KCl is in fact the correct formula. Now that you have the correct formulas, now you can balance. Okay? And so to balance, maybe I should rewrite this in the next page. So we've got MnCl3. I'm going to create a new page here. So we had MnCl3, and we were reacting it with K3PO4. And again, I still need to take up 2 lines. Sorry about that. And we're going to have MnPO4 as the products. And maybe just KCl. We don't need to worry about those threes yet, because potassium and chlorine are going to come together in a 1-to-1 ratio because of their charges. So now I can go through and balance. And this is the fun part, because there's only one magnesium, one manganese on each side, so that's already balanced. There's one phosphate on each side. The only thing we have to worry about is these threes, and that's easily remedied by putting a 3 right there. So balancing that was really pretty easy. And just remember, like we say in class, you never balance a reaction with subscripts. You always do it with the coefficients. So when you're predicting products, always remember, you write the products write the correct formula first. Don't worry about how many of each atom you have at that point. It's important to first write the correct formula. You can balance later. So keep that in mind, give these a try, and see how you do. And questions. Okie doke, bye.